our final example, we have a car slowing from an initial velocity of 20 meters per second by a braking force, and it's asking you what the car's velocity is after 2.5 seconds. And how long would it take using that same force to come to a stop? So we know that our mass is 2,500 kilograms, and the initial velocity is 20, which means that our initial momentum is 2,500 times 20 gives us 50,000. And our momentums don't have to be this large, it's just we have used examples of cars and trains, so the masses are large and the momentums are going to be very large. We have that the force is equal to negative 6,125 newtons. And for the first question, the time is equal to 2.5 seconds. And it's asking us to solve for the V2. Well, in our impulse momentum equation, we don't have V2, but we have P2, and we can use our mass to solve backwards for that. So we can say F times time equals P2 minus P1. And I'm going to show the algebra in this because it's got addition and subtraction, which I know throws some of us off, just because we're not used to doing it. Remember that a newton is a kilogram times meters per second squared, so this just cancels out one of the seconds. And we know that the algebra here is not hard, it's just we don't often add or subtract, so we forget to do that. And to solve for P2 here, we're going to add 50,000 to both sides. So our P2 is equal to 3,487 kilograms times meters per second. So that's our final momentum after 2.5 seconds. And we know that P is m times v. So equals mass is velocity. And so if we divide by our mass, we get that our final velocity is equal to 14 meters per second, and I rounded to two significant figures because of our mass. And we know that this is our V2 because this was our P2. Now the second half of the question asks if we're using the same amount of force, how long would it take to bring the car to a stop? So in the second situation, we are saying P2 equals 0. What is the time equal to? So we have F delta T equals P2 minus P1, and the force is the same amount. And the P2 is 0 in this case. So we would do the 50,000 divided by the force. And we would get that it would take 8.2 seconds to bring the car to a complete stop. And this is only going 20 meters per second, which is about 45 miles per hour. That's a long time to stop.